Hello guys, this video is going to talk about the chemistry behind a simple chemical cell. So let's get started. A simple chemical cell is something that can generate electricity by a simple chemical reaction. So in a chemical cell, usually we consist of two different parts. The first part is the solution, and in this example, then that would be the copper 2 sulfate solution. This acts as an electrolyte, which provide the mobile ions for the reaction. The second part of the cell is a pair of metal couples. In this case, it's copper and zinc. Usually, they are different metals, so they actually acting as the electrode of the chemical cell, and usually they made up of different metals. The chemistry behind a simple chemical cell is actually quite similar to a reaction that you have learned before, which is called the displacement reaction. For displacement reaction, the more reactive element is going to change into the ions, and the less reactive metal ion is going to turn back into the element. If we consider the example here, you can see there is zinc metal and also copper 2 ion. So actually zinc is the more reactive metal element, so it is going to lose its electrons to the copper 2 ion. Then they are going to react, the zinc losing the electrons to form zinc 2 plus, and also the Cu2 plus gain the electron to form copper metal. And in a simple chemical cell, the reaction is a little bit different, right? This reaction still it is going to occur. However, now the zinc is connected to the copper by using an external wire here. And when it is connected to a less reactive metal, usually the more reactive metal tends to lose its electron to the less reactive metals. So in this case, zinc is still going to change itself into zinc 2 plus. However, the electrons is not directly given to Cu2 plus inside the solution, but the electron is passing through the external wire to the less reactive metal here. Alright, so you can see the electrons is transferring to the copper, and zinc here is still losing its own electron and becoming zinc 2 plus here. Okay, so this is for the zinc. And when the copper metal gain the electron, it can't accept the electrons and then become Cu minus or Cu2 minus, because copper cannot form any anion. So it's going to find someone to take the electrons for it. And in this case, there are an cation in the solution, which is the Cu2 plus. So it is positive, so it can take the electrons and then going back and become the copper metal here. So actually, it is still the displacement reaction. Zinc here is losing its electrons and then forming zinc 2 plus, and also the copper 2 ion is taking the electrons and then becoming the Cu metal here. The difference between the displacement reaction that we have learned before and today's reaction is, in displacement reaction, there is only one site of reaction. They occur at the same place. However, in a simple chemical cell, it separates into two different places. Zinc losing electrons in the zinc strip, and then the copper 2 plus ion getting the electrons from the copper strip. So it separates into two different sites of reaction. And because of that, you can see the electron is passing through the external circuit. The flow of electron generates the electricity. So that is the reason why a simple chemical cell can generate electricity. After knowing the chemistry behind, then we are going to see what question will be asked for this kind of setup. In this kind of setup, usually there are three different types of questions. The first one, we will ask you to write down the chemical equation. And second one, because we generate electricity, so we want to know how the electrons are flow. And the last question is about the observation of the chemical reaction. To start with, we are going to find out which electrode is going to lose its electrons and then become the ions. And usually, the more reactive metals is going to lose its own electrons. So in this case, zinc is more reactive. So it is going to form ions. So the first question about the equation, we know that zinc is going to change into zinc 2 plus. However, the equation is not yet balanced here, because you can see we have zinc. However, there is no charge here, but with 2 plus on the right hand side, so the charge is not yet balanced. The difference of charges between two sides is because of the loss of electrons, zinc losing its electron and to become zinc 2 plus. So we are going to add some electrons into this equation such that the charge on both sides is balanced. Students usually get confused because they do not know how to put the electron into the equation. So what you should do is actually comparing the charge. So on the left hand side, the total charge here is 0. And on the right hand side, the total charge here is +2. Electron is something negative, so it should be added to the side which is more positive or less negative. So in this case, right hand side is more positive than the left hand side, so we are going to add electrons on the right hand side. And how many electrons should we add? It based on the difference between the charges here. So 0 and +2, the differences is 2, so you need to add 2 electrons. So this is how we do the equation. And similarly, on the left-hand side, we are going to find someone to take the electrons from the sink, and copper is not going to take any electron because it cannot become copper minus or 2 minus. So it is going to find the ion inside the solution, and in this case that is the copper 2 plus ion. The cation is going to take the electrons. So Cu2 plus is going to take the electrons. When it take the electrons, it will become copper metal Cu. And again, the equation is not yet balanced because of the charge. You can see we have 1 Cu, 1 Cu. Okay, so the number of atoms is balanced. However, we have 2 plus here, but no charge here. So we do the similar things. On the left hand side here, the charge is +2. Right, 2 plus, right? And then here we have no charge, so it's 0. Electrons should be added to the side which is more positive or less negative. So left hand side now is more positive, so we have to add some electrons. And the differences between left and right is 2, so we are going to add 2 electrons here. This kind of equation is actually quite different to the one that we have learned before, because in the previous equation you will not see any electrons inside the equation. However, in this case, we have only one reaction occurring here, but it separates into 2 different parts, so we also separate the equation into 2 different parts. And usually, if it's in a complete equation, we cannot see the electrons here, because if you match them together, then they transfer the electron directly. You cannot see the electrons. But in this case, because the electron is going to pass through the external circuit, so we separate them into 2. And that's why we call this 2 equation the half equation. So the half equation means that the equation with electrons shown in the equation. And sometimes people may also ask you to write down the overall equation. That means it's the normal equation that you have learned before. You can't see any electrons inside. That means you have to add these 2 equations together and to remove all the electrons here. So if you want to remove the electrons, of course, then you have to add the same number of electrons here. So for example, in this case, 2 electrons, they are balanced, then that would be all right. Alright, so what you're going to do is the Cu2 plus, the left hand side, we copy them together, plus 2 electrons, and also the left hand side from this part, plus zinc. Okay, so you can see all of them are from the left hand side. And then they are going to form something. So we copy the right hand side together. So they are all from the right hand side. Okay. The last step, we are going to see whether something can be cancelled out. We have 2 electrons in the left hand side, and then we have also 2 electrons on the right hand side, so they can be cancelled out. Then the equation here is actually identical to the one that you have learned in the displacement reaction. Cu2 plus change to Cu, zinc change to zinc 2 plus, so it's identical to the previous one. Then that is the overall equations here. Sometimes the half equation, for the number of electrons, they may not be the same. Then you have to pay attention to them. Maybe you have to multiply the whole equation by 2. Alright, so we will map this case later, so we talk about them later. Alright, so that is about the equation. And the flow of electron, you can see for the copper 2 ion is taking the electrons, and then for the zinc ion it gives out the electrons. So we can already see the electrons go from the zinc to copper. And for the one which give out electron, we will say this is the negative pole, because negative they repel each other. So the negative electron is go out from the negative electrode, and then positive negative attract each other, so electrons go into the positive pair. So copper is the positive electrode while zinc is the negative electrode. So that is the flow of electron. And then the third one, the observation, basically it based on the equation that you have written down. So for the observation, for example, for zinc this side, you have to look at the state of different parts. So original zinc is a metal, and then it dissolves to form the aqueous solution. So you can say zinc dissolves, or you can say the zinc electrode becomes thinner because it dissolved it, so it would becomes thinner. Alright, so that is the observation. And similarly for the copper side, okay, because copper originally is aqueous and then it becomes a Cu metal. So well, it's difficult for you to say, okay, brown solid attach on copper because they have the same color, right? So we usually say the copper electrode becomes thicker, because actually something is attached on the copper and they are identical, so it's hard to tell. Okay, but then at least you can know it becomes thicker. And also because Cu2 plus originally is blue color in the solution, and then it becomes Cu, so that means there are less Cu2 plus in the solution. You can also say the blue color of the solution fades. That means it becomes paler, or you can say, okay, it becomes paler is also okay. So this is what kind of common question that may be asked in your exercise or in your exam. So that's it for today's video, and I will give you another example in the next few seconds, so you may also try it, and I will also provide the answer for you too, so you can check it out. Okay, so see you guys, bye.